You might have heard of this term in system design interviews or while managing servers, right? But a proxy server is that middleman between your computer or the client and the internet. Okay, reverse proxy sits in front of our servers. Okay, these are our servers, which protects and optimizes them. There are three major reasons for using forward proxy in your network. The first reason is anonymity and security, and the third reason we use load balancer is to improve the overall performance of the server. Let's see how do we combine both the reverse proxy and load balancer. Hey everyone, welcome back to the channel. So today we are going to untangle three terms that are often discussed in the tech world: forward proxy, reverse proxy, and load balancing. You might have heard of this term in system design interviews or while managing servers, right? But what do they really mean? Stay with me because we are breaking it all down with some real world analogy and use cases. So this is our fourth video on the system design basics playlist, where we cover all essential high level and low level system design concepts in detail. So you can go and check out the other videos in this playlist also. Okay. So now let me just change the slide. Let's start with the simplest one first. That is a forward proxy. So imagine you want to order a pizza, but you don't want the pizza guy to know your address or location. So what you do, you call a friend and ask him to order for you. And your friend, in this case, your friend acts as a proxy, right? So in tech terms, a proxy server is that middleman between your computer or the client and the internet. Okay. So it forwards your request to the internet and then sends the response back to you. So imagine you work for a IT company and the IT team says no direct internet access is available for you. So sounds harsh, right? But instead, all internet traffic is routed through the forward proxy. So why do companies do this? So let's break it down. So there are three major reasons for using forward proxy in your network. The first reason is anonymity and security. So the proxy acts as a middleman. So employees' devices never communicate directly with the external website, right? Instead, the forward proxy makes the request on their behalf. So this hides their internal IP address, making it harder for attackers to trace the request back to the company's network. Okay. So that's the first benefit. The second benefit is for access control. So IT team uses forward proxy to block specific websites like social media or streaming services, ensuring employees stay focused on their work and do not access random content while inside the company network. So the third benefit is content filtering and malware protection. So the proxy can scan the outgoing and incoming traffic for malicious content, which stops the malware before it reaches the employees' devices, right? So these are a few benefits of using forward proxy and the main reasons for using forward proxy. And now you can add a cache server into the mix as well. Imagine a team of employees constantly accessing the same external resources. Let's say they are accessing a same website or let's say same weather forecast API. So instead of fetching it from the internet every time, the forward proxy can store the data, frequently requested data in the cache server, and then transfer the data to the employees whoever is requesting the data. So here is how it works in detail. The first request for the data is fetched from the internet and then it is stored in the cache. For subsequent requests by other employees, let's say there are other employees who are requesting the same data, then the data will be checked whether it is present inside the cache or not. If it is present, it will be fetched from the cache and served to the employees instead of browsing the entire internet every time. This is especially helpful for companies with limited bandwidth or high traffic volumes. So pretty cool, right? So I've created a separate video on caching. So you can click on the I button to explore that video. There we have discussed about caching in details, like its types, okay, different type of cache and eviction policies, and a lot of things we have discussed. You can go and check it out. Well, now that we have discussed about forward proxy, let me just change the slide. So now let's discuss what is a reverse proxy. Now just flip the script, okay. So let's say you run a popular pizza delivery service. You are not ordering, but you are delivering pizza, okay? And you don't want your customers calling your chefs directly, right, to prepare the pizza. So instead, you have a front desk or reception which receives the order from the customer. It verifies the order and then routes them to the right chef present in your kitchen. So this is the job of a reverse proxy. So unlike a regular proxy or a regular forward proxy, which protects the client basically, if we see here, it protects the client, right? Client means whoever is browsing the internet or whoever is using the browser. So it protects the client, but if you think about reverse proxy sits in front of our servers. Okay, these are our servers which protects and optimizes them. How? Let's say your company has a website that has a massive hit, like millions of users are viewing its content or sending requests to this website. So you cannot have all the users directly accessing your servers, right? So it can be a security loophole. So this is where a reverse proxy comes in. A reverse proxy sits in front of our servers and handles incoming requests. Okay. Now there are few other reasons and use cases for why reverse proxy is used. The first reason is traffic routing. So as you discussed, it directs the incoming client request to the appropriate backend server. Okay. Then the second most useful reason is security, because this reverse proxy hides the actual server's IP addresses, which makes harder for the attackers to get target of the specific servers. Third reason is for performance. As you discussed, just like forward proxy, in reverse proxy also we can attach it with a cache server to cache frequently requested data to serve the users faster. So common examples of reverse proxies are Nginx, HA proxy, and Elastic Load Balancer of AWS can also act as a reverse proxy if it is configured to act like so. Now we discussed about reverse proxy. Now let's just discuss about load balancers. Okay. Now how it is different from reverse proxy. Now just think about a pizza delivery problem. Let's say your pizza becomes super popular. So one chef cannot handle all the orders that are coming from the customers, right? So you'll need multiple chefs. And you need someone to split the orders among multiple chefs, right? So that's where the load balancer comes in. So in a tech world, load balancer distributes incoming traffic from the users to multiple servers for preventing overload on a single server, for ensuring high availability. So even if one server goes down, let's say this server goes down, others can still handle the request. And the third reason we use load balancer is to improve the overall performance of the server, because we are not overloading a single server with all the requests that are coming from the users. So load balancer can operate in two layers. The first one is it can operate either in layer 4 or transport layer, where this load balancer distributes traffics to multiple servers based on their IP address and ports. The second type is the layer 7 or the application layer, in which the load balancer makes decision based on the content of the request like URLs or cookies, and then decides which server to send the request to or to send the traffic to. So examples of load balancer: AWS Elastic Load Balancer, then Google has its own cloud load balancing services, and Azure also has something called Azure Load Balancer, and Azure Application Gateway is also there, which can act as a reverse proxy also. However, I've created a separate video on load balancing where I've discussed in details about the types of the load balancer, different type of load balancing algorithms. All those stuffs are discussed, so you can go and check out that video. Click on the I icon above to check it out. So now just think of a scenario, okay? So imagine your website has multiple servers. You have a website running for you, and it has multiple servers behind it. So a load balancer distributes incoming traffic across the servers, as we already discussed. But what if a malicious actor, let's say this user is a hacker, let's say, okay, or a malicious actor who tries to overload your servers with a DDoS attack. So DDoS is kind of sending, in short, if I tell you, it's kind of sending a huge amount of requests in a short span of time so that it will overload our servers. So in this scenario, what will you do? Let's go to the next slide. So here's where the things get exciting actually. So in this scenario, we can combine a reverse proxy with a load balancer. Let's see how do we combine both the reverse proxy and load balancer and harness the collective power of these two. So here in this DDoS attack scenario, we can combine reverse proxy along with load balancer. So here in this case, the reverse proxy acts as a shield which can filter out suspicious traffic. So once the traffic is verified, then it forwards the request to the load balancer. Then the load balancer can distribute request evenly across multiple servers or backend servers that is running. So by working together, the reverse proxy and the load balancer can protect your backend infrastructure while maintaining high performance, availability, and security. So it's like having a receptionist, which is a reverse proxy, then a dispatcher, okay, which is a load balancer, then the chefs. So these servers are your chefs who will be preparing your pizza, right? So all of these are working in harmony to run your pizza so efficiently and smoothly. So now that we talked about security by using a reverse proxy along with load balancer, let's see which type of security features does reverse proxy provide. Okay, so the first security feature that a reverse proxy provides is the IP masking. So what does IP masking means? It means hiding the real IP address of our server, so that attackers, if someone attacks, let's say there is a hacker sitting here, so they cannot target our servers directly because they don't know the direct IP address of these servers. So while sending back the response from server to client, the reverse proxy can mask its IP address, right? Reverse proxy will mask the server's IP address for security. So the next benefit security feature it can implement is rate limiting. So rate limiting is nothing but reverse proxy can control the number of requests that the users can make in a given frame of time or a given span of time. So this is a very useful feature where it can stop bots, right, or the hacker bots from spamming your servers. So the next security feature of reverse proxy is WAF or web application firewall. So many reverse proxies include a firewall that can block malicious traffic like SQL injection or cross-site scripting attacks, right, or DDoS attacks. So this kind of malicious request, it can filter it out and it won't send it further even, right? Which secures your entire backend architecture. So with reverse proxies, your servers become really a fortress, right? So to wrap it up, as we discussed, a forward proxy serves the client and it secures the client, making the internet browsing secure for the clients. And the reverse proxy serves your servers and secures your servers by managing and optimizing and incoming traffic. And a load balancer ensures that no single server is overloaded or overwhelmed, keeping things running smoothly by distributing traffic among them in a even manner. So there are multiple algorithms for load balancing. You can check out that load balancer video for details. So I hope this cleared up your differences between load balancer, forward proxy and reverse proxy. So if you found this video helpful, smash that like button and subscribe to my channel and hit the bell icon for more such useful conceptual videos on system design basics. So also check out my playlist on system design where we combine system design concepts with real life use cases. Click on the eye icon to explore the playlist. You can also check out my other playlist named Learn Out of the Box, where we discuss about this type of interesting tech topics that you are seeing in this list currently. Like topics like how Netflix prevents screen recording, or how Spotify recommends song, or how to check if a user exists among billions of users. So this kind of interesting topics you can check. So check it out, you will definitely love it. So if you got any doubts about whatever we discussed in this video, put them in the comment section and I'll be sure to answer them. So we are targeting to reach 1800 subscribers by the end of this month. So keep supporting. Thank you for watching this video and I'll see you in the next one. Thank you.